retire. So they just said, we'll just kind of lean it this way a little bit because of that absolute destruction that he got when he faced the Seahawks.
Yeah.
All right, we're back. Should have ran it instead of threw it like it's the Patriots. Okay, let's see. Where are we at here? Low power. There we go. That's what I want. From current slide. Okay. You guys may remember this. We spent a little time into the past. This is when we first started our time together. We reviewed this the first day, I believe. It's got some cool information in it for us. Before moving on, we must review electrical symbols. It's funny. Electrical symbols. Okay, what do we got there, gentlemen? Normally open contact. All right. Okay. Everybody got a capacitor there? Okay. What does it do? Close on rise. Yes. Closes on rising temperature. Good stuff. What do we got there? Okay, thermostat open on rising temp. Good job. Normally closed, so to contact. Sound like it. What is that? This guy right here. Whoa. Look at you guys go. Close on. Close on. Close on. Yeah, that's for that. Let me ask you this real quick. When we're talking relays, we see one of these in here. What is this going to do when we energize the relay? Yep. Okay, good. All right, now what did we say this one was? Close on drop. Pressure switches that opens on a rising pressure. Okay, well, I don't know about all that. It doesn't look like that. It seems like that should be shut. Should be across, right? It's going to open when you have a rise. Okay, so, makes sense. Are you serious?
Don't ever take Donnie seriously.
Okay. Did you study that page in the back of your book?
Okay, you can take it serious now.
Not one in the back? Here, right here, this guy, remember? Did you study him? Yeah, you got one there too. Study the wrong one. Oh. Yeah, it's the same. Donnie, what's that one? Yes. What is the electrical principle that allows this to happen? Magnetism, yes. But more importantly, induction. Magnetic induction. Yep, magnetic induction. Transformers. Whoop.
Pressure switch.
Hey, don't let everybody answer yet. Let me call on somebody.
Okay.
Samuel Seth Huntington. Thermal relay, I think is what this is. Thermal device. I believe in our book, let's check real quick. Back section of this book. Thermal.
Cut out with a little arrow.
Thermal relay. I believe that is what it's calling. Thermal relay. I believe that's what it is. Okay.
Yeah, they're exactly the same.
One says thermal relay, and one says actuator. That's the difference. Symbol's the same. Makes sense. If you're talking the symbol, there's no difference. If you're talking what an actuating device is, I'm going to think of an actuating device as with an overload. Like you'll notice up here on the three-pole circuit breaker with thermal overload device in all 3 poles. That's the same symbol. The actuating device is actually like a little bimetal strip that's inside an overload that once it heats up, it opens, and then that's what trips the overload. So that's what I'm going to say an actuating device is it's the actual part of the overload that opens the trip when it gets hot.
So an actuating device like that,
It'll be right. Yeah, yep. Yep, that's why we can get away with using the same symbol. You're so silly. Yeah, I think you do too. Okay. What's this one? You should have him. Actually, yep. It's not. I think it's on this. It's a float. Float switch.
Flow switch. Wow.
This is flow.
There is a flow switch.
Those are nice.
Increase in flow. Whoop, damn it. Fusible link.
Fusible link.
Good job, Bruce.
Thanks,
Okay, nobody answered.
yeah, nobody answered.
Steve. W. The outside one is what I was going to say. The one far away. This one's actually going to be a thermistor. Okay, that ain't on the test.
Ground. Something else.
Oh, it's one of those spinny top things, you know, it's a wire.
Okay, the next person I want Chris to answer the next one.
That is a light.
Okay, Steve, you're next.
I'm next. Oh, I guess.
First, Steve or first?
Resistor. Oh, I think that's
Resistor. Yep.
okay.
Bruce, you're next. Low pressure.
You basically did.
No, I didn't. Shut your dirty mouth, Chris. Oh, Lance? I think so. I think they're trying to illustrate the size difference there, single phase. Usually on a schematic line diagram that these are going to be on, that will be the symbol even if it's a 3-phase motor. Okay, and that's the same symbol regardless of what the phase is. On a pictorial diagram and some of the other diagrams, you'll actually, like a wiring diagram, you'll actually see 3 different wires coming off them, but most likely in a schematic, that will be the symbol for a motor. Elko.
Push button.
What kind of push button? Normally,
Those are nice.
normally close push button. Normally close push button. Normally close monetary push button. Okay. Ooh, Donnie. Good one. Here it is, right here. I know you've seen this in a slideshow from me. We've talked about it several times. I'll even give you the trade name, Clicks On. Anybody know it? Who said it? Heat sensor. Yep, it's a call it Clicks On or bimetal switch. Same thing. Same thing. Yep, that's not on your test, I don't think.
I didn't see it.
Yeah, I don't think that one's in your test, but it's important to know, especially if you're looking on the schematics and you see it. You know what it is. Where are we at? Dennis, my man. Don't overthink it. Yep. Samuel? I do believe you're right. I do believe it is a fuse. Yep. Steve? Don't overthink this one either. Very, very close. Very close. It's a coil. That's a common for a coil. Christopher? What's it gonna do?
It's gonna close on decrease.
I think what this, yeah, I think that's what it's gonna, this one should be closed right now. So it can indicate that it's closed right now and it's gonna open on rise. Yeah. All right, Steve. Light. And you already knew that one. Okay. Bruce?
I want to say fuse, but I don't know. I might need help from the audience on this one.
I think you're right. I think you're right. I think you're right on this.
That's smart.
Okay, Lance. Booyah. Coil. Another word for that is inductor. What was that?
Just some important stuff.
A toy from the toy box? Oh, hey, be quiet for a second. What was it? Thermocouple, yes, sir. Yes, sir. A little different. Note the difference between that one and the one in your book.
Yeah.
Remember that one in the book, please. Looks like a pencil. All right, now we get into some wires. Donnie. How many's in there? What are they? What's happening with that circle? What do you suppose that's meaning? Typically, where do you see a circle in your world? Cable. Look at that. This one would be 2. Actually, there's only 2 in there. 2 wires. Multiple conductor cable. Okay. Dennis. Shielded. Okay. Yeah, that, I think. Yeah. That I think that is typical, and I believe that is even what it's telling us in your guys' book here that the dash lines are field installed. Yep. So, Samuel, my man.
No idea.
Let's see. Did we do? Nope, that was the other class. So this right here is going to be a plug. There's a buttload of plugs out there. That's the symbol for a plug. Got something kind of like right here. Me and the second year guys actually saw one of these on the print, and it was just one of those arrows like that with another wheel on there, just one single one. So that's going to be a plug. Okay. Steve. It looks like you'd think it's a 3-way. You think it is, and it should be drawn different. But look at how this circuit is going to lay out. So basically, we got 3 switches in series here, right? That's not what we want to see. That's not a good symbol. Disconnect or gang switch. You're never going to see 3 switches on the same line. We're going to have different power coming to each pole on the switch. So that's a little bit of a different one there. So this one is in your book. It's noticed they're small. Field control. Low voltage conductor field installed. I believe we're on Chris.
That is a motor.
How many phase?
Single.
Single phase motor. Steve? Tell me about that.
That is a full switch, close on rise.
Okay. I like it. Brucey? Brucey poo? Is that what mom calls you?
Usually it's more, get back here, stop running from the dog. No. So I'm getting.
We got some belt problems in your life, don't we?
Yeah.
Back on topic, sir.
Yeah.
We just talked about it.
Diode.
That is exactly right. It is a diode, but in this case, we're talking about. Oh shit! I thought that was a plug. I thought we had a single plug, but yeah, you're right. You're right. Look at you go. Lance, take over for us, sir. Ooh. Now, high voltage conductor installed inside the unit. Elko? Yep, three-phase motor. Boom shakalaka. Downey. Nope, it's not a spring. Yep, it's a momentary contact, normally open, momentary contact switch or push button. Dennis. Probably, yeah. Inside the unit. Samuel? How much? Sounds right. High voltage contactor installed in the field. Steve? Three-phase what? Transformer. Why connect the transformer? You guys don't know about that. No big deal. So here's one. Specifically, we talked about it, Chris.
That'd be your, I want to say relay.
What's this mean? You're right there. What does this add to it?
So thermal.
Thermal relay. Thermal relay. Okay. There it is. That's the one I was looking for. Plug. Connector. Same thing. Bruce, you got a guess on that? We didn't talk about it. Selector switch. I would figure that'd be not quarter, sir. That's not. Lance. How many phase? This is probably going to be a magnetic motor starter. Thermal circuit breaker. Okay. Good enough. Elko. Remember the V in this one. That's important. What does V stand for?
What?
Voltage.
What?
Voltage meter. Yep, that's what it is. A voltage meter. Okay, next. Donnie, you got a guess? Push button switch. I think you're right, though. That is something other than that. Give us that one, would you, sir, Donnie? That one may be the magnetic motor starter. Because of the coil, yep. So that coil in there is indicating that it's going to be magnetic. Anytime you got a coil, there's going to be some sort of induction or magnetism going on. Dennis? Single pole, double throw. Yep. Sam? Yeah, I don't really even remember that one. Make or break. Make before break switch. Answer this one for us. I don't know that one either.
Still no clue.
Segment contact, how about this one? So the other kind of configuration of a transformer, do you guys remember any of that? Yep. Delta transform. Sam, I want you to answer this one. That one's in your book. Yes, more specifically though, what are these conductors doing? Yes. Yes, sir. Wire crossing. Steve? Yep, it's more specific. Right there, it does say it. I can see it from here on your book. Termination. Wire junction. Right there in the middle. I can see it from here. See it? Right. Same thing. Okay, Chris? What in the ear hole?
It's going over.
Jumping it over, right? Jumping right over it. Wire crossing. Steve? Oh, I think that's it on that. Yep, that's all. That's all she wrote there. Stop. Collaborate and listen. Okay. Everybody get on that? You see any of them in your book that you think that you might want to talk about right now or anything like that? Okay, good. All right, I'm going to get rid of him real quick. And now I want to talk a little bit about this page. Oop, not insert. Slideshow and current slide. Okay, gentlemen, let's talk about this. Spend a little time up here on the whiteboard talking about this circuit here. Spent a little time the other day with it. Let's throw up a theoretical statement here. Okay, I want it to be cooling. I can see manually by looking at it that our C contactor is pulled in. If I look at it, I can look right here and see that it's automatically pulled in. I see this little bubble right here. See that? I know that I'm getting a call for cool. Okay, I see that come on, but neither my compressor or my outside fan motor are turning on. What is the problem? Contacts. Most likely, this contact is open, right? Should be closed because we pulled the contactor in, but it's open. So if I were to want to read across there with the voltage meter, what would I expect to see at that point? What do you think I drew that on there for?
Showed us the power supply.
So right now,
If the
I'm essentially, if this is open right now instead of closed, I'm essentially reading from right here to right here, right?
reading 240 volts.
Absolutely, absolutely.
Because it's not, because when the switch closed, once you read 0 volts, if you're again on the switch, then you would begin.
That would be, if that was closed, it would be like reading from here to here, right? And it's the same wire, so there's no voltage difference between those two. 0 volts. It would actually be something along the lines on your meter. Something like that, volts. A millivolt reading, depending on what the readings on your guys' individual meters are. There will be a little bit of voltage drop there, but yes, in the big picture, that should be almost 0 volts. Okay. All right. Line that back together. Okay, so let's get rid of him for a second. Now, I'm going to add a little something in here. You'll see a print sometimes that has another set of contacts right here. also coming off of this C. And I don't recall exactly if this is in your test or not. I've made a lot of tests lately. But say the same situation. I look and I see that that one's pulled in. And I come up here and my outside fan motor is running, but my contactor isn't, or my compressor motor isn't. Then what do we think? That set of contacts, right? That set of contacts that is specific to this group right here. Because we still have, if this one's pulled in, we still have a path to be able to send this, right? He's going to run. But if this guy isn't, and we have one of these, and there is a spot in your book, although I would never like to see this, because we do have a possibility right now, we are essentially single phasing this motor. It's never a good thing to have. So, okay. Seems like there was one other thing that I wanted to talk about here. I may have to find us a different drawing to talk about. Yeah, that's exactly what I'm going to do. One more thing here, real quick. Okay, we're going to talk about heat. Man, it's cold in here. Let's turn the heat on. So I get my fan, or I get my call for heat. My heating contactor comes on, so that's going to close here. I'm going to hear also indoor fan motor is going to come on, right? Because I have this path. So that should be on. That should be going through. And it should be going here. Well, geez, man, that indoor fan's been running for a while. It's not warm. No hot air coming out there. Still cold air. It's just like it's getting pushed around. What do we think might be happening? Fuse. Yep. Fuse probably blew. Why do fuses blow? Overcurrent. There are overcurrent protection. A great way, and it happens all the time with overcurrent protection, is when this opens up. When that opens up, boom, we got a either that opens up or it shorts. That's another way to happen. If that shorts, boom, we blow that fuse every time. Don't just throw another fuse in there and try to solve the problem, right? Fuses don't just blow for no reason. They have a reason to blow. So if you throw another fuse at it, you might as well grab two fuses. Most likely it's going to blow. Okay, any questions on that? Okay, let me go find this other drawing that I wanted to look at real quick. Shouldn't take but a minute. I think I remember right where I put it. 35, 27. Let me get some bigger pictures here. All right, let's talk about him real quick. So, from here to here, L1, L2. When you see this on a schematic, what are you going to assume the voltage is? 240. Yep, most typically, you'll see a 240 volt when you have L1 or L2. What happens if this wasn't L2? What if this was? And what would the voltage be? 120. Yep. So we're going to assume that this is 240. It's not 220 and it's not 230. It's 240. So I got my meter set up down here, reading across here, and I want to move. How I'm going to go through this is I'm going to put my meter in each one of these switches. Now, assume that I have this happening. I have all of these switches until I get to right, and I want to do one more right here. So at that point, if I read my meter from right here to right here, what should I read? Nope. 240. Yeah, 240. Where'd my eraser go? It's just that. I don't want that one. I want the blue one.
I'll tighten that.
Oh, good. It's right here. Right here where I left it. Okay. So I still have my meter here. Still got my meter there, and I should read 240. What happens if I read 0? What does that mean? If I read 0 at this point right here,
Switch 6 is from, the switch is closed.
okay? Switch is open, I would think. No, switch would be closed, right? If I read 0, it would assume that all of these would be closed, right?
Yes.
So we would essentially be reading just across that, but it actually wouldn't be that, because it'd be the same as this. We would still read the entire voltage, right? What happens if I read 0 is I've lost a connection from this point, from where I'm metering. I've lost one from here back. Okay? Everybody got that? So it could be that this switch has opened. It could be that this switch is open. It could be that that switch is open. It could be that that switch is open, and it could be that that switch is open. But it always is going to be that the line from this point to L2 has opened. It's always going to be that, okay? It doesn't matter which one, it's just that one is. Okay? There may be a reason why I brought this up. Hint, hint. Okay? But the line from where this is back to L1 has opened in that case, if you're reading 0. Okay, moving on. One other drawing I wanted to look at here. Them are too easy for you guys. You'll figure those out in a second. Okay. That other one is right up here at the top, it looks like. Get off of me. Okay, that's what I wanted right there. All right, let's get rid of this stuff. It looks to me like what kind of voltage is happening on this circuit? 240, yes, sir. Okay. What's this? Yep. Yep. All right. So. This is very similar. This is what I was talking about earlier about how it has this content in here. Yeah, I kind of lost where I wanted to go with this. At this point right here, voltage meter. With this picked up, what should I read there?
240.
Yep. Yep, I should read 240 right here. Now, if I read 0 volts on there, what does that indicate? Which, okay. Yep, I agree, it's a contact.
One in between the two leads.
Yep. It could be this one, right? Or it could be that one. Because if that opened up, we now lost our circuit, right? We no longer have this path, and we could no longer have that. So we would just assume at that point that, hey, look, most likely, if both of them opened, we need to check our actual contactor to see if it's even pulled in. So, right? Boy, I'm kind of wearing thin on stuff to go over on this. You guys have any questions? Any questions on schematics? Let me just touch the. I'll look at the. I'll look at the test real quick to make sure that we went through everything that at least once that you guys should know. And then we should be good to go. New window. My WDT. That's me logging in. Faculty. What class is this? 135. You guys want to take a break real quick?
Sure.
Okay.
Do we need our calculators? We're doing any calculations?
Let me look. I'll look right now. Yeah, all 150 of them. Whoop. $47 questions. I just added 5. Yes, you will have a test, a question on this test where you will need your calculators or the calculator on your computer. It may have something to do with what we talked about at the beginning of class. All right. Get started here with this whenever you guys get back in. For Dick and boys? Oh, well, at least hopefully it was with a girl. Have you guys wired a split phase air conditioner yet? No? Okay, I think we're going to move into that. You got to do split phase air conditioner and what else? Let me see here. Let's see what Uncle Keith wanted us to do. Wiring split phase air conditioner and wiring packaged air conditioner, wiring split system air conditioner, and yep. So we're going to do air conditioners next week, and then we're going to move into motors the following week. Motor fundamentals. Steve, did you get your computer to work?
Yeah, I'm working up right next to that.
Right on. Okay, So I'm gonna pull up, and I want you guys to look, but I don't want you to do anything yet. Hide that right here. I don't really want to stay here and do your guys' lap.
You don't,
No, I need to though.
give us another problem to solve and come to the lab.
No, I need to do that lap.
What is it anyway?
My problem is that I don't, like, I have to run home and let that puppy out. I gotta do puppy Friday. Well, I gotta do it Thursday too. So I would like to be able to do it. What time can you guys be here tomorrow morning?
Oh, tomorrow morning? The class starts at 8. I have to drop my son off, so usually like being here at 8.
Early as you can get.
Yeah.
Can you, let's see.
If we get it Thursday, I can be here at 8 also. So that would be an hour and a half before class.
I have another class. No, I see not. You know, we might be able to get it done. Let's just plan with it. Let's see what I want to go over the test. But yeah, I only have like an hour between your class and the next class, and I'm gonna let that puppy out because I don't want to shit in the box. Yeah, yeah. I got home Friday night and I was like, so my father-in-law from Colorado flew in, and he was there, and I walked in and I saw that puppy. And I'm like, he's already got 3 dogs. So I'm like, why did he bring a puppy with him? You know? And then I said, I double checked. I just wasn't making sense. I wasn't making the connection. And I said, why do you have a puppy here? And my wife goes, well, you've been complaining about being lonely, and I know that you've been wanting a dog. So happy Valentine's Day. She says, here's your new puppy.
Stop being lonely.
Yeah. You know, I used to train hunting dogs when I lived actually out here, and then when I was in high school, I trained hunting dogs. And
Labs too, or-
yeah, I had an awesome yellow lab when I was in high school, and then I trained through further. So back where I'm from, Presho, that's pheasant hunting is a huge deal. That's no. I could. It's almost identical, same thing, except for the commands are a little different and how you want it to behave. But yeah, I trained a few for some of the. There's big, huge pheasant ranches that are there, and places make a gobble money. Got one. My dad guides for one on the weekends. That place just during pheasant season makes $1 million just for hunting them done pheasants. Yeah. Yep. Okay, guys, let's get started here. I wanted to show you guys this real quick because it is a little different than maybe what you've seen in the past, because there is 2 parts to this. So please pay attention to the screen. So here's what your test is going to look like. What I want to direct your attention to is once you get through this section, do not submit, because there's 2 pages here. You have to, once you finish that one up, make sure you click next. And then you have 19 multiple choice. Okay? And then once you finish both, then you can submit. So there's 47 total. So if you got 20 done, don't think that you're finished. Okay? Everybody clear on that? Okay. If everybody wants to get their computers fired up and get to the My WDT, I will go in here and make sure that this thing is open. Bruce, if you're going to use one of those, will you please go down the line? Move at least one away from Steve. I don't need you cheating off of Steve, okay? I don't know. Steve claimed to know. Can you put your, can you use your ID number maybe?
The computer ID, that one Bruce is on, already had me log in for that, so I don't know what that would be.
Try your ID number, and then if you can't figure it out, I'll ask Charlie. So this is going to be the electrical drawings test, and I'm going to open it now. Resistors in parallel quiz. I got 3 fellas that got that. Chris, Stephen got it. Stephen Christopher. Lance got it. Donnie got it. Donnie even sent me a message about it. Steve, did you want to do that quiz? The resistors in parallel quiz? Or did you do it that day we were here? Were you here that day that we did resistors in parallel? Did you get some answers for me?
No.
Would you like to? You don't want 10 bonus points? Okay. You don't want them. No credit. Did you get logged in, Steve? Do you know how to log into these computers in the back? Super. Super duper. I thought so. I thought they did. Why don't we head you up to the library then, sir? Is that where you're going?
Yeah.
Okay. You figured out, Bruce? Oh, Steve, he's kind of grumpy sometimes, ain't he?
That's always.
That must be kind of shitty to walk through life being mad at everything all the time.